Unit 9B, magnitude and direction angle of a vector given the component form. So what this is that if you're given the component form of a vector and they want you to find the magnitude and the direction angle of that vector, you would only need again these two formulas. This vector formula to find the magnitude here, and this theta to find the angle of the vector. Example: if you're given a vector that has an x component of -3 and a y component of 7, to find the magnitude of the vector, just plug it into this given formula here, where you're going to take out the x, plug in -3, take out the y, plug in 7, work it out. So this is 9 plus 7 squared is 49. So this would be square root of 58, the magnitude of this vector. To find the theta, the angle of the vector with respect to the standard position, you would have to use this formula, tangent inverse of y over x. Y is 7, so it would be 7 over -3. Theta would be, plug it into a calculator. You would probably get a different number than 113. That's because you find the given value would be on the right side of the y-axis. So you would have to subtract it from 180, and then that would give you 113, which is the correct angle. Okay, moving on. What would be the magnitude of this vector and the angle with respect to standard position? Again, plug it in. Square root of -2 squared plus -3 squared. It's going to be 4 plus 9 is square root of 13. So the vector, magnitude of the vector, square root of 13, that's the length of it. The angle would be tangent inverse of -3 over -2, which should be tangent inverse of 3 over 2, which would give you a positive angle that you would have to add to 180, because this is in the third quadrant. The vector is in the third quadrant, so it would be 236 your angle.